All right, everybody, welcome back. In this video, we're going to finish up with section 6.8 of AP Calculus, finding antiderivatives and indefinite integrals, basic rules and notation. We're going to pick up right where we left off in the last video. And we'll start by looking at, these are some basic integrals involving inverse trig functions that we should recognize, namely that if you see something of this form, 1 over the square root of 1 minus x squared dx, that's going to result in an arcsine of x. Same thing if you see 1 over 1 plus x squared dx, that's when we take the integral of that, that's going to result in an arctangent of x. And if we see the integral of 1 over x square root of x squared minus 1, that's going to result in an arcsecant of x. And both the first and third rely on the fact that the absolute value of x has to be less than 1. Otherwise, this expression is going to, how shall we say, blow up. Actually, give me a second, wait. That should be a greater than there. The absolute value of x has to be greater than 1, because if it's less than 1, this is going to be imaginary. Sorry about that typo. Alright, so having fixed that, let's go ahead and move on to example 3 and look at applying and finding a bunch of these indefinite integrals. Alright, so in part A, I'm going to think about this as the integral of 2x to the negative 2/3 minus 7/8 times 1 over x plus 5 over quantity 1 plus x squared dx. Now for this one, I'm just going to apply the power rule. So the antiderivative of that is going to be 2, and then I raise the power by 1. So that's going to be x to the positive 1/3 divided by 1/3, and I'll simplify that momentarily. And then the antiderivative of 1 over x is the natural log of the absolute value of x. And then for this last term, I've got 5 over the quantity 1 plus x squared. Notice the resemblance there to this. That's just a constant multiple 5 times the arctangent. So this is going to be 5 arctangent of x plus c. And then I'll simplify this answer down. Dividing by 1/3 is the same as multiplying by 3. So this becomes 6x to the 1/3 minus 7/8 natural log of the absolute value of x plus 5 arctangent of x plus c. Okay, the next one. Integral of 3 cosecant squared of x plus 2 secant of x tangent of x plus 5 over the square root of 1 minus x squared. So again, we're going to just find the antiderivative term by term. The derivative of cotangent is negative cosecant squared. So the integral of cosecant squared is negative cotangent. That's going to be negative 3 cotangent of x. The antiderivative of secant of x tangent of x is just secant of x. And then the antiderivative of this, we've got the constant multiple 5. And when you see this square root, 1 over square root of 1 minus x squared, should recognize that that's an arcsine based function. So this is going to be the arcsine of x. And there's my indefinite integral in part B. All right, part C. Integral of e to the pi plus x to the e minus 3 times pi to the x. Holy smokes. All right, so as we go through and analyze what's going on here, we've got a bunch of things that look very similar but behave very differently. This e to the pi is just a constant, and so the antiderivative of that is just going to be that constant times x. All right, then we've got x to the e, so we've got x raised to a power. So the power rule tells me that I'm going to raise that power by 1 and divide that by the new power. So that gives me x to the e plus 1 over e plus 1. Then we've got a constant multiple 3, the minus 3. And then the derivative of pi to the x, that's something of the form b to the x, and so the antiderivative of that is going to be pi to the x divided by the natural logarithm of pi. Don't forget your constant of integration. And there's your integral in part C. Okay, now let's look at part D, and I'm going to go over here and I'm going to deliberately do part D wrong. Okay, we're taking the integral of the quantity x squared plus 5 quantity squared. What you might be tempted to do here, since we've got a quantity raised to the second power, is just to say that the antiderivative of this is going to be 1/3 times the quantity x squared plus 5 to the third. You might be tempted to say that that is your indefinite integral. However, if you stop and think about it, what happens if we take the derivative of this? Well, we've got 1/3, and then we have derivative of the outside, leaving the inside the same, times the derivative of the inside, which is 2x. And if we simplify all of this, we see that this is actually the antiderivative of 2x times the quantity x squared plus 5 quantity squared. And we cannot just divide by 2x to take care of that. You know, if it were just a constant, yes, we can just divide by a constant, but we cannot divide by a variable expression because, you know, you think about it, when we take the derivative, when we have variable expressions, things behave a whole lot differently than when we have constant expressions. We've got constant multiple rules for both, you know, derivatives and integrals, but we don't have variable multiple rules for those. And so this is something, you know, we want to avoid doing it the wrong way. My only recourse in this problem in order to do it is to actually just use a little bit of algebra first and expand this out. This is x to the 4th plus 10x squared plus 25. And now that I've expanded that out, now I can go ahead and find the antiderivative term by term. So this is going to be 1/5 x to the 5th plus 10/3 x to the 3rd plus 25x plus c. And this is the antiderivative of the quantity x squared plus 5 quantity squared. Okay? Sliding down a little close here, while there are many indefinite integrals that we can find by simply applying our derivative rules in reverse, there are going to be even more indefinite integrals that require more advanced techniques. We're going to learn some of those techniques yet in this course, and even more in future courses. For instance, in Calculus AB, we're still going to learn about using integration by substitution, and we're also going to learn about how to use long division and completing the square in order to turn problems into ones that we can integrate. And then in BC calculus, we'll learn about integration by parts and partial fractions and stuff like that, so that we'll have more and more techniques to find the values of our indefinite integrals. All right, that's it for this section. See you next time. We'll be back in section 6.9, which we're going to break down into multiple lessons, each of which will probably have multiple videos because it's an extraordinarily important and, one of the more difficult topics. It's more difficult than what we've been doing. So we're going to break it down a little bit along the way. All right, have a great rest of your day, everybody. See you next time, and enjoy yourself.